Hello, everybody. Welcome back. We are live. Hope everyone's having a good day so far. Let's go ahead and pop open the Discord. Let everybody know we're live. All right. Tired today, everybody. Mondays. Gotta love them. Okay. What do we want to do today? Let's figure that out. Okay, let's just dive in. Let's not waste any time here. Let's get into these problems. Okay. So draw the recursion trace for the execution of the function in code fragment 410. 415, 414, 413, figure, code fragment 412, code 411, 410. Okay, let's pull up our handy dandy whiteboard. And let's give this a try. So draw the recursion trace for the execution of function reverse. So we'll say R S 0 and 5. That kid, dude, welcome back. It's good to hear from you. How are you doing today? Let's get the lava lamp going, yeah? You get the lava lamp going. Alright, let's get the lava lamp going here. Alright, and boom. Sweet. Nice. How you doing, that kid, dude? Thank you for coming in today. Alright, so so first executes the function of s 0 and 5. So our goal is if our start becomes less than our stop minus 1, we do the following: sequence at start, sequence at stop minus 1 equals start so our recursion call we will recurse down, right? And we will call R of the string S and start plus 1, so 1, and stop minus 1, 4. Right? We don't really care what's happening on this line here. Nothing is actually happening in terms of like mathematical. All that we're doing is just swapping elements in this array S, and so in thus reversing it. So we don't really need to worry about this because we're not performing anything actually on our individual values until we call the recursion here, right? We're not, so this would be a tail recursion where the recursion is called as the last line in the function, and so there is no other operation happening to it per se in this example, right? So I'm doing good, trying to think of a programming project I can work on. Oh, nice. What kind of stuff do you do in like your everyday life that you can maybe like optimize, or that you like just what kind of hobbies you have. Start there. Okay, so then we call R of, so if star is less than stop minus 1, so start is 1, stop is 4, minus 1 will be 3, so we're still good here into our program. So R calls on the sequence S, we increase to 2, we decrease to 3, right? So if start is less than stop minus 1, keep going through this. So now on our next recursion, it's not less than or equal to, so this would be our base case here. Our base case is met, and so we don't return anything. We don't return anything to the function itself, right? We don't return a value anywhere. This just generates a new array, right? So for this array with 5 elements, it would only take 3 recursion calls to, or 3 calls to the function to reverse this array. Right, so in the first call, those 2 would swap. In the second call, those 2 would swap. And then we're left with the 6 in the middle. So first call, the 6 and the 4 swap. Second call, the 3 and the 2 swap. And we're done. Yeah, so the 0 and the 5 swap. The 1 and the 4 swap. And the 2 and the 3. Interesting, yeah. Hey, General Talks, thanks so much for coming in. How are you doing today? Happy Monday, happy Monday. Okay, so my recursion trace, I think, would look something like this. We would have reverse, some sequence S with some start 0 and a 5, right? We would then come down and call reverse on a sequence S with a 1 and a 4. We would then call reverse on sequence S with a 2 and a 3, right? Would we call this function actually? It wouldn't enter into this if statement. It would get called, but nothing would happen. So nothing actually happens on this, this nothing, right? This is the else condition that's met, right? So you swap here, you swap here, and then you do nothing on this one because 3 minus 1 is not less than 2, it is equal to 2. So we cannot move forward with the reverse, meaning that we've found our middle character here, our middle index value. Cool. So then this would be, right, index S0 and S5 are values, elements S0 and S5 swap. Elements S1 and S4 swap here, and then no swap to less than 2, 3 minus 2, not true, right? So this would say, like, if is not true. Okay, cool. So that would be my recursion trace. Now let's give that to the almighty orb, see what it says. Come on, come on. Show me the money. So everybody says, initial call S05, second call S14, third call S23, unwind call, reverse, returns to reverse 05, reverse 05 completes and returns. Recursion trace. Sweet. Nice. So I'm right. Tell me I'm right. Yes. Aha. Cool. That was an easy one. Don't get too ahead of ourselves here, guys. Just because that one was easy, these other ones might come quick. They might get difficult quick here. All right, 4, 5. You got pi. Okay. Draw the recursion trace for the execution of function puzzle solve 3SU in code fragment 4.14, where S is empty and U is ABCD. Ooh, here we go. 4.14. Let's try this one. All right, puzzle solve. Oh, it just showed us that. Well, hold on. I guess we'll see. Okay. Kind of just flashed us that answer, no? Okay. So we need to solve a puzzle. Oh, I guess these one would be a different call, right? But whatever. Okay. No, they have it 3SU. Okay. It's the same puzzle call. For UABC, though. Oh. Okay. So we have a UABCD now. Okay. So puzzle solve, K is an integer, S is a sequence, and set is U. Output an enumeration of length of K length extensions to sequence using U elements without repetition. So if K is equal to 3, we make words of 3. So what would K be here? If K is 3, okay, let's just try it out. This might get crazy here. Let's see what we got. Okay, so draw the recursive trace for the execution of function puzzle solve 3SU. So we have puzzle solve P, which takes in 3, which has a sequence value and a U variable. So for each element in the U set, do add element to the end of S sequence. Is S sequence empty? Add the element E to the end of the sequence S that's in our U, okay? Remove E from U. So we know that our U, hold on, let's first go like this. Our U is a set of A, B, C, D, right? So in order to call this function, so if you add e to the end of the set, or end of the sequence, the array. You remove e from u. If k is equal to 1, then test whether the sequence is a configuration that solves the puzzle. If the sequence solves the puzzle, then return solution found S. But what is our puzzle? So if we had, for ABC, we have initial call of 3. Just scatters all 3 of our values there, like so. But we have 3 recursions deep. This one's going to have 3 recursions deep, but a 4 bound. So it would go like this. So our puzzle solve recursion just reduces k by 1 and takes an element out of our set here and appends it to our sequence with every iteration. Okay, let's try it out. So this, we have a 3 out front, so we're going to have a recursion 3, a k equal 3 deep, right? Meaning that we are, or we're searching for desired value or something. Okay. So if we go ahead and draw a line, we're going to need a lot of lines here, so let's just make things broad. Boom. Boom. Boom! Got that in my head. Right, so this one's going to have 4 because we have 4 values in this set. So our first recursion is going to call P for k minus 1, right? Our k is going to reduce. A value, we will say A is going to be added to our sequence, and it's going to be removed. Oop, that was terrible. That was terrible too. From our set. So it's going to be B, C, and D. All right. In this recursion, we're going to have P2 with B out here, and our set will now have A, C, D. Right? In our another recursion here for every element in E, right? We have 4 elements in E, so we will be doing a 4 levels of recursion at each k depth, right? K level depth as we go deeper. So in this one we have P of 2. We'll take C this time, and we'll take our set out front equal to B or ABD, right? And then our fourth element at this current recursion stack level is k is 2 because we reduced round down by 1. We have D in our set in our sequence now, and we have A, B, and C in our set, right? Cool. Now we're going to, this is going to get pretty dense here, guys. So we're going to go down 1 here. Because this has 2, right? K minus 1. So we have to show every combination of A with B at this stage. Oh, okay, at the one level, if K is equal to 1, you return solution found, and then if, say, test whether the K solves the puzzle. So at this point, K is down to 1, right? So we have P, K1. We're looking like A, B, C, D still on our set, right? So then it would be P1, A, and what would we do here? At K equals 3, right? If K equals 3, you go down by 1, you meet your base case at K equals 1. So for 4 elements, though, at K equals 3 for the sequence. So in this iteration, for every element E, and you add E to the end of S, remove E. Oh, so from the end. So this one's going to call it AB, A. So we need to go down more. Ooh. Like this. This one's going to call it P1, A, C, set B, D, right? And then it's also going to call P1 A, D, and then the set B goes over, C goes over, now D goes over, and you have level BC, right? So now you have ABCD, ACBD, ADBC. Now we're going to have 3 calls here. So let's go like this. 1, 2, 3 of P1, B remains in our sequence. A comes out of it and gets paired with B, leaving C and D left in our set. Our next call instead takes K down to 1, right? B is initial. C goes inside of our set is A and D. Right? And then our next call, man, it's getting tired here. It's Apple Mouse is hard. P1, B, D, and then inside of our set is A and C, right? Now this one calls 3 functions along the same lines, and then this one does the same thing. So, right, we start with A, then we take B in, boom. And the other one we take C in, boom. And the other one we take D in, boom. We start with B, we take A in, boom. We start with B, we take C in, there. We start with B, we take D in, there. All right. This would be C, D, or no, C, A, B, D. This would be C, B, A, D. This would be C, D, A, B. And this one would be D, with A, and then B, C, and then D with B, A, C, and D with C, A, B, just like that. All right, that was a long one. Now, the difficult part is we're going to have to try to convey this somehow. How can we convey this? Okay, let's go like this. P 3, 5, and then this A, B, C, and then D. Right? So this function gets called initially. It gets that we call 4 function. We call 4 functions for this recursion down. So this becomes, let's go down one more like this. This becomes P2 oh, this is some sequence, right? So this becomes P A goes in the sequence at this point, and in our set remains C, B, and D, right? Cool. Next, we get P. I'm just going to copy this guy, paste it here, here, and here. Okay, this one, B is our starter. Why do we say C, B, A, D? What the heck? A, no, B, B, C, D, right? B, A, C, D. It's going to be C, A, B, D. And this one's going to be D, A, B, C. Okay. Our next call, I'm going to tab these twice, each of them. Like that. Okay, cool. That's a little bit more organized. I'll stretch this so you can see. So this is our initial call right here. Okay, our next level. Oh boy, how are we gonna? It's gonna be hard. It's gonna be a lot of lines. Here we go. Okay, let's just get into it. P1, we take, not B, this is B, C. We take B out, we put B here. Right? And then in our next call, we take B out and put C in. And then our next call, we take B out instead, put D in. Okay, that chill. All right, like that. Cool. Nice. I'll just go like this. This is going to be too difficult. We'll just go like this. Take this away. Paste this down. Take this away. Paste this down like that. This is going to be... Okay, so now we'll take these guys, paste them here. Oh, nope. Just take one, I guess. Paste it here. So now P1, instead we have B out front. We have A, C, and D. I'll take this guy. Oh, come on. This thing is so annoying. Paste it here. B's, this, oh, so we need to take the A out of here. We take the C, put it here. Just take the C out. And then the next iteration, we take the letter D out. Swap it with C. Like that. Okay, and then in this one, we start with C, right? And we're going to initially take A, thus leaving B and D. In this one, we're going to start with, we're going to take B, leave A and D. In this one, we're going to leave D, or take D, and A and B remain. Okay, now one more time, guys. Thanks for bearing with me here. Long problem. D, we take A, thus leaving B and C. I'll copy this guy, paste, we take B, leaving A and C, and in this guy, we take C, leaving A and B. Let's see if GPT likes it. Visualize recursion trace for let's see if it works. Top level 3 A B C D, right? Second level is ABC with BCD, ACD, ABD, and ABC. Awesome. Second level A B C D A C B D A D B C B A C D B C A D B D A C. Nice. C A B D C B A D C D A B. Nice. And D A B C D B A C and D C A B. Woo! So level 3, selecting the third. At this level, we now have two partial solutions of length 2, and we must select the final element from the set U. So P becomes 0 still. Oh, do we need to call one down again? Oh. No, they stop on 1. If 1, test, and if the puzzle return the solution found. So they stop on 1 in their example here. So if I paste in this, it'd probably adjust it. Base case is k equals 1. Awesome. Level 2, mechanism level AB. Level 3, k is equal to 1. Boom, done. Awesome. That's the answer to this problem. That was a long one, guys, so sorry that one took a little bit, but we were able to work through that and get the answer. Nice. We need to rename this as R 4.5. Okay. Now, what? R 4.6. Okay. 3 more problems. And then on to chapter 5. All right. Describe a recursive function for computing the nth harmonic number h sub n is equal to the sum of n I equals 1 for 1 sum of all values n where I equals 1 ninth harmonic number. So how could we make a recursive function that would do this? Oh, this is going to be tough. Hey, Jonah, thanks so much for leaving a message. Yeah, I'm losing my mind, that's for sure. We are grinding through this. Thanks so much for stopping in and saying hello. Appreciate you stopping in. Okay, describe a recursive function for computing an nth harmonic number with this algorithm, this mathematical equation. So the nth harmonic number. Hey, Dat Steele, thanks so much for coming in. How you doing today? Harmonic number. Where did it talk about harmonic numbers? Okay. Further analyzing the max finding. A more interesting question about find max is how many times we might update the current biggest value. In the worst case, okay. Um, So to answer this question, note that we update the current biggest in an iteration of the loop only if the current element is bigger than all the elements that preceded it. If the sequence is given to us in random order, the probability that the jth element is the largest of the first j elements is 1 divided by j, assuming uniqueness. Hence, the expected number of times we update the biggest, including initialization, is the sum of all the where j starts at 1 and goes all the way to n. Okay. All right. Christy, the recursive is pain. Yes, we're going to try another. We're getting into another describe one. We're going to write one here. So we're going to try to do this. I'm going to need you guys' help. That's for sure. Yes. Hey, Justin, thanks so much for coming in today. How you doing? Welcome, guys. Hey, Vanch. Good to hear from you, man. Welcome back, you guys. Welcome to the zone. Okay, so we have a harmonic, which is going to take in some value takes in some sequence S, and we'll take in a harmonic H, right? So this is going to be an int. So in this function, our goal, come on, stop that. Why? Why is my, okay. In this function, our H, we're going to find, returns the probability that the we need J. Returns the probability that the jth element, or the blank element, the nth element in the largest is the largest of the first j elements is 1 divided by 2, 1 over j. So the first element would be 1 over 1, 1/2, 1/4, and we sum all of those. Okay, so we need to return the probability that that H okay, I see this doesn't feel like it should be that hard. So we need to have a base case. So our base case is if j becomes greater than n, right? Because in the length of s, right? So if j becomes greater than the length of s, meaning that we have, so the length of s is going to give us, if let's say we have a sequence S1 which is equal to some random uniqueness. So 4, 2, or let's say 1, 3, 7, 9. Right, let's just do that, right? Random and unique, right? And they're all getting bigger, so it's just how it is. Or I'll make 9 here just for an example, and then 7 here, right? Let's try that. So if j, which is going to be the index value for these positions, becomes greater than the length of s, we need to return in our base case this is tough. Just finished my final, so ready for the holidays. Awesome, that sounds super great. So is our base case if j becomes greater than the length of s? So if s is 4, the length would be 4. J becomes 0, 1, 2, or 3. So that would be the length of s minus 1. So 1 over j. Oh, this is tough, guys. H of n. So this takes in some sequence n, rather. Takes in some sequence n. And some value Do you have any resources for me to learn Python? I know some Python, but not so much. I'm trying to grind. Yeah, for sure. I initially started. So my name is Michael. For those that don't know and they're new to the channel, I am 25. I have a Bachelor of Science in Human Biology and a minor in chemistry. I work as a formulation chemist, and I'm teaching myself code after my 9 to 5 job, just as a to gain more skills and to have a hobby and you know. And so I started about 6 months ago. I started with Harvard CS50P, which is the Python course. It's a great course for Python. I would, if you're going to do that, I would highly advise you to pair it with Python Crash Course, the book. Um, this book will really just help you kind of keep up with what's going on in the lectures. The lectures don't really do that great of a job from a raw beginner's standpoint, but the book will help you to just kind of pick up where what they mean with certain syntax things like backslash. I had no idea what backslash n was until I kind of got into like the book and paired it, because they kind of skim over some stuff in the lectures that raw new beginners wouldn't really understand too well. So it was difficult on that front, but when paired with Python Crash Course, it's a great option. I created a Discord linked below where I've compiled all my study resources into one location. And so if you're interested in getting all of those, I have the PDF of the Python Crash Course. I have my personal notes when I went through it my first time. On my channel, I have links and videos to the Try It Yourself. I am creating and have created solution videos to the Try It Yourself practice problems inside of Python Crash Course. And then right now we're doing DSA, which is getting into really more advanced stuff. DSA in Python, data structures and algorithms. And then we have Fluent Python right here. And then we have Python machine learning. So we got a lot of books that we're going to get into. And yeah, so any of those options, like starting with CS50P, Python Crash Course, moving your way up to maybe Fluent Python and DSA in Python, and then going from there is a great way to. I think that's the map I kind of took, and everything is in the Discord. So if you want to access that, then join there, and yeah, it's really fun. I announce my streams there, and yeah. So the harmonic takes in some value n, which is known as the nth harmonic number. So the probability that the jth element is the largest of the first elements is 1 divided by n, assuming uniqueness. So we sum all of those probabilities up to that element. So you have to give a sequence j, right? So you have an n, and then you have a j that you have to provide as well that you need. No. So n in this case would be our ugh. So prefix average. So they take n's length s. They create. Okay, so we need to take the length of n, which is our sequence amount of data, right? This is going to be what do they set equal to? N is, so they take in some sequence s, and they say length of the sequence is n equals to length of the sequence. So then we also provide a j value, and we return the probability of the sum of all those probabilities up to that jth value in the sequence. So n is the length of the s. So if so we have some function, right, where we will call harmonic obviously back into our function. We will call it for sequence s with j plus 1. So j is going to increase by 1 every time in our sequence. So we need to set what j is. For j in range of n, so n will provide us 0, 2, 4. So j will be 0, 1, 2, or 3, and 4. So we're going to loop. We're going to capture the index value over our n sequence, and we're going to call recursively harmonic is equal to it's going to return a value, right? So this is going to be val. This is called the what? It's going to return the sequence. Okay. So we have a value that's returned by harmonic, and we increment j by 1 every single time. So then we have to have a base case that says if j becomes greater than our sequence of n, so j would be 0 greater than n, we need to return return what? What do we need to return here? Return val? No, because we can't set return val when we set it down below. So we have to include also this function here. So harmonic Nolan says return 0. So if the j value, if our index goes greater than n, meaning that, no, because this is just going to loop through all the values of n and won't, it's not going to reach this base case of j ever reaching greater than n. So we have to say greater than or equal to n, return so we need to return. This is tough. I'm so sorry, guys. So we have s at index 0 all the way to j. So in this function, prefix averages, they say for j in the range n, total equals 0. So they set a counter. This is tough. Should we draw out like a recursion trace for it? Do you think that'd be easier? So we take in j. We would go j1 over j plus 1 to get to the next value in j. But we wouldn't even need a sequence though, I don't think, right? Because you're wanting to just know if I'm given a value of j, what would be the odds that, so you need to be just given a value j, right? You just need to give a value of j in our harmonic. And knowing that, what it will do is it will return the harmonic number at that index value j. So we'll say we need to create an array. So we'll have blank equals a blank array, right? We need a blank array where we will then multiply we'll have 0 in here times j, right? So we're going to create an array of elements through j. If the sequence is given to us in random order. Okay, so we had to, actually we do have to be given a sequence. So I'm dumb. Sorry, guys. So then sequence, we're given a sequence. We need to get an n from that, which is going to be the length of the sequence. Right? If j for all the values in the range of n, this is j is going to be 0, 1, 2, 3, or 4. We need to take we can say count equals 0 here and say so 0, 1, 2, 3, or 4 will be j. So we'll call harmonic when divided by j summed all the way up to j. For value j through there. No, so we'll say for index of in there. We need to access for index in the range. We need so for every index in the range, we need to, in the range of n, we need to call the harmonic function. This is such a struggle. I feel so dumb. I don't know. Like, this just really makes me feel so small, to be honest. So I'm sorry if this is not entertaining, if you're beating the screen because this is so easy for you, but you know, I'm just being realistic. I'm not trying to sugarcoat things. Like, this is hard for me, like, to wrap my head around. Like, putting these functions into code. Like, it's like for all the values, we need to sum, so we have to keep a count somewhere. And we need to return that count. So value was this, and we need to return value, return count plus equal value. Right, so this will add value. Or sorry. This will add value to our count. No, we need to say value. No, we set count plus equal value, right? So we call harmonic, but we need to call 1 divided by the harmonic because we have this 1 divided by no, we need to have that be inside of the function here and call harmonic again within the body for j plus 1. So we need to have the actual functions here. 1 for I in index 1. We need to go value equals one divided by I so 1 divided by I, this will have, like, if they provide a 2 here, this will be 2. No, because it's j. We need to go up to j in our sequence. The structure is similar to the power function. Let's take a peek. Where was that at? This one? I feel like I'm letting you guys down. I'm sorry. Okay, so in our power function, in code fragment 412, wait, why are we in chapter 3? Were we looking at the wrong problem? Harmonic. It's all the way back in chapter 3 is where you learn about harmonics. Okay, let me turn off my heater real quick. Okay, let's see if we can try this again. So let's take a peek at that power function. Factorial. Where was that power function at? Good Fibonacci, linear sum, reverse, power. All right. Fuzzy Games, thanks so much for coming in. I appreciate your stopping by. Thanks so much. Just got here, but seems chill. Do your thing and learn. Awesome. Thank you. I appreciate you. Yeah. Jocelyn, do you go to school too for CS? No, I graduated already back in 2021 with a bachelor's in human biology and a minor in chemistry, and I work as a formulation chemist. And so I'm doing this all independently through my own motivation and desires and wanting to stream and talk to you guys and make connections and stuff. So yeah, it's really cool, and I really appreciate you guys being here and supporting the channel. And yeah, right now we're working on a recursion problem that we cannot solve because we're struggling, to be honest. So we have harmonic. We need to take a sequence S and provide an index J and return back to the user that. So we need to go all the way through our sequence, compute the harmonic for the last value, or compute all the harmonics up until we hit J, right? So for value I in the range of n, that will capture the index position that we're at. And then we need to say for in the range of n, we're going to, now that captures the index value. So what can we do with those? 0, 1, 2, 3, and 4. Well, we need to go up to J. So for whatever so actually we'll say for index in the range of not the length of S. We don't want to go to the length of the S because we don't want to compute the total. We want to go to the range of 0 to J, right? So this will capture all of the index values up to the J that we were provided. Okay, that makes sense to me. So I don't think we need to do anything with this. Let me type back in my harmonic and see what it takes us. Right? So we go for index values in the range of 0 up to J. We are going to compute 1 divided by I, and we're going to value equals 1 divided by I at that point. We need to add value to count. Right? Okay, so we now are computing the harmonic number for the element at J, or up to every element up to including J. So we need to actually include J. So this would be J plus 1 right here, right? So now we're including the element J. So if we say that we want to go up to the third element, which would be the 9, we need to say J plus 1 to get access to the third element, because range does not include the upper bound unless you go up by increment by 1. So we'll increment J by 1 to include J just by the nature of the range function. We will compute value, which is the harmonic value. So I'll say harmonic value. Harmonic value is equal to 1 divided by I. I don't think you need the 0. Okay, let's get rid of the 0 then. Yeah, this will just go up to range up to J plus 1. Thank you for that optimization. We're good there. So we compute the harmonic value, which is 1 divided by J, and we append that to count. But what we're doing, hold on, guys. If we call recursion on this, right now it's going to compute every harmonic value up through J, which is a for loop here. So this is defeating the purpose of the recursion call, right? We're kind of computing this manually now, using O of n time. We're computing every harmonic value up to J, when we need to be computing this in log n time. So I don't think we should be doing this, right? We should be calling recursion on 1 divided by J plus 1 and adding that to count. So we should be calling harmonic on sequence S of J plus 1, and we need the value. So this is going to return. We need the harmonic to return a value all the way through J. No for loop then, just call the function and change the values passed in. Right, okay, yeah, so we call the function harmonic, we change it to this. We call harmonic instead of the for loop. And then we have to do 1 divided by the returned value of this, and harmonic needs to return. So if something, right, if yada yada, then we need to do this. No, I'm sorry guys, this is a struggle. So what would be our base case then? Like our base case would be met if j is equal to I, right? The index. So if j becomes equal to I, we need to return harmonic no Ben 2 says yes, that's the right. What are you referring to, Ben 2? One divided by harmonic of the sequence j plus 1. Harmonic needs to return a value though. How can we make harmonic return a value? Within our base case, it needs to return a value, right? But this is going to compute a value here, so this is what it's returning. Like, GigaShorts, yeah, we're working on data structures and algorithms in Python right now. We're almost done with the end of chapter 4, recursion practice problems for the reinforcement. So we've been working through this, reading it aloud. Thanks so much for joining. I appreciate you being here. So 1 divided by harmonic j plus 1. Well, I just don't get where we go from here. We have to go all the way. We're including some n variable as well. The sum of all the values of n. Oh, so we are computing it for all the values in n? I thought we're providing a j. Oh. Okay, I'm dumb. I don't think we're providing a j. We're providing a sequence, and we take the length of the sequence. We're going to save this as n. So n will be the length of our sequence, so in this case it'll be 4, right? We are going to say, might help how to write it out, how to solve it by hand in a comment too, so you're coding to be more concrete idea. I like that. So here's our whiteboard with our other trace that we did. Let's delete this. So we're going to start out with a value. Let's say we're going to call harmonic on some sequence of on some sequence, right? S. So let's say that the S is 4, meaning that we get 4. if j, so we say if else call do this 1 over harmonic j for I in range n plus 1. For I in the range n plus 1, we want to return, if want to compute the harmonic of sequence at index I. So this is going to 0, 1, 2, 3. No, because this is going to compute that harmonic value for each iteration. So we don't want to do that. We want to compute it. We want to break this down. So I don't think we need to be using a for loop here, but how are we, what are we doing with this index value? H3, yeah, so H3 would be like just 1 over 1, 1 over 2, 1 over 3. So we return 1 divided by j plus 1. But I'm getting thrown off by this harmonic call here with the inside. Like, so we need to return a value inside of our base case. So what is our base case then? Like, that's what we need to establish. If j is equal to n, right? Meaning that we have computed all the way through j, computed all the way up to n. If j is equal to n, we want to return 0 because we return 0 back in. No, we want to return j, right? We want to return j so that j can get filled into this harmonic. So it's going to go up to go to the 1 right here. It's going to go to the 1. It's going to say, okay, j is not equal to the length of s, right? So we need to compute the harmonic value at this place. Okay, so j is not, so else we need to compute the harmonic value. We do 1 divided by j val equals 1 divided by j, and we call harmonic again for j plus 1. Devin, yeah, we're working on data structures and algorithms in Python right now. We're reading this textbook, trying to write a recursive function for computing the nth harmonic number. I'm struggling real hard, if you can't tell. No shame here. I'm a beginner programmer. I'm self-taught, so yeah, I will struggle, but when I do learn it pretty decently. So just trying to grind through these and using your guys' help here. Appreciate you being here. I like to use comments to describe each step in the algorithm, then implement the code under each comment afterwards. That's a good idea. So we need to, if j is equal to n, meaning that we have reached our last position in our sequence, right? We have reached our last index position in our sequence. So j has become n. We need to return what value to the function? Or just return 1 over return count, like a counter, because we have to compute the sum, right? So harmonic has to count somewhere. So do we need to count here equal to 0? If j becomes n, we want to return count we have reached our last index position in our sequence. So we need to return, we have reached S, so now we have reached 7. So now we need to compute the total, we need to return the total count, right? Because we're going to start at this one place. Because we're going to call harmonic 3, which is going to compute 1 over n index 0, 1 over n index 1. Oh, this is ridiculous. I feel like this is so much easier than I'm making it, but I just cannot wrap my head around it. Gosh. And maybe return 1 over j plus harmonic 1 j minus 1. If j is n, we would compute 1 over j but not call the function again, right? Meaning that we need to compute 1 over j if j becomes n, right? Because we still have to do it at this place. So j has become n. So j has become n. So we need to compute 1 over j at this point and return this value. Count equals this. If j is equal to 1, return 1. So j is our index value. If j is equal to 1, why would you return 1? Meaning that j would be 3. I'm not sure if that is correct. If j is n, you would compute 1 over j but not call the function again and just return the 1 over j. Okay, we return 1 over j if j is equal to n, as that's our base case, meaning we have computed here, computed here, computed here, and computed here. No, but we don't want to use j equals n because it's only going to compute it at j equals n. So we need to reduce n. Oh, this is ridiculous. Yeah, this is data structures and algorithms in Python. I appreciate you guys being here and enjoying my struggle working through this problem. Recursion is really tricky for me, and okay, so we take the length of n, the sequence provided. Do we need to do this anywhere? That's fine, and only do it for the last element. But we need to return a summed value of all of these. That's the whole point. We have a sum happening here, right? Right here, we have a sum happening. So we need to have a count keeping track of each of these increases, right? But we need to, we might, are we looking at this the wrong way? Do we need to do we need to go through all the way to the end and then compute and go back up and return each value and sum from there? Because if that's the case, we need to have n be in our function somewhere, right? If n is equal to 1, return. So if n is equal to 1, we want to return 1 over j, meaning that one over n index 0, right? So that'll compute. No, we don't want to compute that physical value. We want to compute 1 over n, right? Because n will be 1 in this case. But that'll just compute over and over again. I don't think we're wanting this to be our base case. We should sum through the recursion. Yeah, so... Oh my gosh, why is this so hard? I cannot... Let me get a piece of paper. Okay, so I had one here. Yeah, if n is equal to 1, it'll just be 1 over 1. So this is not our base case. We need to come up with a different base case. Okay, so if we take the harmonic of 3, it's going to do harmonic of 2 and compute harmonic of 1. Okay, so we need to start at the end of the sequence and work our way back forward. Harmonic so we need to start at the back of our sequence. We're calling the sequence here, which is taking the length. So we need to start at the end here, compute the harmonic for the last value in the sequence. So we'll say no, so we're computing the harmonic, which is just it's the index value. It's 1 divided by 1, starting at 1. So 1 divided by 1, starting by 1 divided by 2, 3. It's like the amount of the data place, indexing with the start of 1. Where did my blanket go? Base case is if you're at the last place in the element. Okay, so let's first set that up. We need to, so if j is equal to the n, right? This is our base case. We need to, what do we want to return at our base case? we need to return, our base case would be oh, this is so annoying. So what do we return? What do we compute here? We compute 1 over 1. We need to return 1 plus 1 over 2. We need to return 1 over 2, or 1 and 1/2 plus 3. No, sorry. Plus so this would be plus 1/2. So this comes back to be 3 over 2 plus 3 over, no, 1 over 3, 1/3. So we need to return and sum we need to return. So we're not computing an index. We're not computing the actual value. We're computing just an index, right? It's the harmonic number. We're not computing 1 divided by 1, 1 divided by 3, 1 divided by 9, 1 divided by 7. We're computing 1 divided by 1, 1 divided by 2, 1 divided by 3, 1 divided by 4. So it's the index, but it's index starting at 1, right? That's the harmonic number for my interpretation of this problem, right? So we have, to answer this question, note that the current biggest is an iteration of the loop only if the current element is bigger than all the elements that precede it. If the sequence is given to us in random order, the probability that the jth element is the largest in the first j elements is 1 divided by j. Hence, the expected number of times we update the biggest is where j is equal to 1. So j is just a starting place of 1, and it increments each time as we go forward in our list. It's just that's the issue here with harmonics that I think people aren't understanding, is that we're not computing the indexed value in our list. We're just computing the place index plus 1, basically. For index so we compute one, we go break this down, we go down all the way through. So else we compute 1 divided by j no, right, we need to return 1 divided by j and call harmonic of sequence j plus 1, right? Now we need to define j. So if j is equal to n in our base case, meaning that we have reached the last, we compute that and return 1 divided by j. So now we need to, if j is equal to n, now anybody have any thoughts? So if j is equal to n, we've reached our last value in our list. But we're wanting to compute and then call. So we want to say if j is not greater than n plus 1, or if j is greater than n, right? If j becomes larger than n, we want to return 1 over j. J becomes larger than n, meaning that so we're going to start here. Okay, our base case is not met, so we are going to this is equal to n. If j is equal to n, return 1 divided by j. Else we need to, what do we need to do? We need to continue forward. We need to increase by 1 on a harmonic. Right? Yeah, it's just computing the nth harmonic number. It's computing the total sum of harmonics in the sequence. That's all it's doing. So it's just we need to return the harmonic and keep summing as we go. And I'm having trouble doing that. Pull up the recursive power function from yesterday. It'll help. So this is the recursive power function that we did. So we have a better, here we go. So if n is equal to 0, return 1 for the function as this plus the value of n. Okay, so let me take this guy, put it over here. So we have a harmonic value provided. If j is equal to the n, j is equal to n, return that value as this function. So this will get returned. So we need to add this to something, right? So this gets added to what? Plus, because the harmonic is going to be returned inside of this for the value at j. We need to add it to our count, like that. So count equals 0. So the function input 1 plus 1. No, not 1 plus 1. 1 divided by 1. It's 1 divided by 1, 1 divided by 2, 1 divided by 3, 1 divided by 4. It's think of index values but plus 1. I'm pretty sure this does def harmonic 1. If n is equal to 1, return 1, else. Yeah, that's what I was thinking. We have to be decreasing our n somehow. Like that's when I think I'm stuck, is that we're not we're not iterating through the list anywhere. Like and we're not trying to do a for loop to iterate, so we need to reduce our actual sequence down each time. So if we're given an n here, we say if n is some value of 5, if n is the length of s, right, which would be 4 in this case. So if n is equal to 0, meaning that the length is no longer, we want to return, right? Okay, exactly. We want to return 1. So if equal to 0, meaning the list is empty, we return a value of 1. Return. Do we set j equal 1 and return j? Because that'll compute. Yeah, I think we set j equal to 1, and that'll compute going back forward, like in kind of reverse. So if we set j equal to 1 and return j in our base case, else harmonic of n minus 1. So if this will continually go down, and we'll return the value of j, which will be 1. We need to compute, though, we need to compute something. We need to compute like a 1 divided by j. Oh, this is ridiculous. Return 1, else return 1 divided by n plus harmonic n minus 1. You don't need the s as a parameter. Take n instead. Just the base case result, right? 1 divided by j plus harmonic. Yeah. Like this. So this is going to return 1 for j if n is equal to 1. And we're going to, so let's say that we do, in this function, let's type this out, right? Let's draw this out. So in this function, we're going to call harmonic at, let's say, 3. Okay, our base case, n is not 0, so we're not going to do anything else. We're going to do 1 divided by j. Well, we don't know what j is, so we can't do this. We don't know what j is. We're going to get an error here. So else we need to call harmonic n minus 1. Okay, this will then call H2. This will then call H3. H3, oh sorry, H1, and then this will call H0. H0 base case is met. We set j equal to 1 and we return j. Here we need to compute 1 over j. One over n plus harmonic n minus 1. So we don't need to return a value here. We just need to return 1 here, like that. I think this is the function. Oh my gosh. Okay, so let's draw this out. I think we're getting there, guys. So h is now 0. Right? So we're going to return 1 here. We're going to return a value of 1. We are going to compute we're going to compute 1 over the n value plus this 1. Right? That's where that comes from. Okay? So this becomes, 2. 2 is returned. Else call two is returned. Don't we need a return statement here? Right? We need a return. So this returns 2. 2 gets put in here. This becomes 1 divided by 2 plus 2. So 2.5 gets taken over here. This becomes 1 over 3 plus 3 over 2. Which becomes 6 times 2, 2 over 6 times 3, 9 over 6. So 2 over 6 plus 9 over 6, 11 over 6, which would be, am I doing this right? This would be times 3. This would be times 2. This becomes 6 times 3, 9 times 2, 2, 6, 6, 9 plus 2, 11. 11 over 6. 6 goes into this 1, so 1 and 1 over 6. Okay, we want to return 0 here, not 1, because 1 over 0 is technically not defined, right, when we're not empty. So this this is 0. We want to return 0 here, not 1. Okay, back it up. Okay, so h sub 0, okay, we return 0. So we do 1 over 1 plus 0. So we return that value, which is going to be just 1. So we do 1 over 2 plus 1. So this would be 3 over 2 is returned. So then we do 3 or 1 over 3 plus 3 over 2. Right? Okay, so you can calculate backwards 1 divided by 3 plus 1 divided by 2. There you go. If n equals 0, return 0, right? The base case should be n equals 1. So if n is equal to 1, meaning that we have one value left in our list, we need to return 1. Or if it's 0, return 0. Okay, so the same thing. So if n equals, you just have one further recursion that wasn't necessary. So we want to keep n at 1. Because you could return 0 at 0, but that would just be one further level of recursion call, returning a 0 value that actually isn't doing anything. So which would be, n would be 0, right? So it couldn't even compute this. Anyways, we get an error. So n has to be, this has to be 1. We have to return 1 here. So let's go to our whiteboard. So we come down to h1, we return 1 plus 1 divided by 2, which is 3 over 2. We return that here, which is 1 over 1/3 plus 3 over 2. Over 2. All right, so we gotta do times 3. So this become 11. This would be the same thing, 11 over 6, which would be 1 over 6. Like that. Oh my gosh. Okay, let's try to see if this is right. Let's go ahead and run. We want to call print on harmonic of 3, right? 1.833. Ooh, what happened? What is the third harmonic? No, number. Okay, oh, come on. Not frequency. So this gives me 1.83, which I don't think is 1 and 1 over 6. Unless I did some math here wrong. Harmonic n minus 1. So this would return 1 as this value. I think I just did my math wrong. Let me do my math again. So we return 1, we compute 1/2, so this becomes 1.5. Oh yeah, okay, I did my math wrong. we do this and we add 1/3 to 1.5, which would be 1.83 about. Okay, cool. So then let me ask the almighty orb here. Harmonic 3, 1/2 plus 1/3. Yep, we did it right. 1.833. Let's go. Wow, only took us like dang near 2 hours. Oh my gosh. Recursion sucks so bad. This is like, I haven't struggled this hard with anything in programming since when I first learned about object orientation. Like, when I first learned about classes, I had this same feeling. But now I'm really good at classes for the most part, like beginner wise. I can write them pretty well. So hopefully this gets easier too. Same mentality. Oh, 11/6, not 1/6. Yeah, I had my, guess I was just reading my own writing wrong. I think, well, thank you guys so much for helping me out with those problems. Oh my gosh, that was just ridiculous. Like, we only, that was nuts. That was way harder than I made it out to be, I feel like. But it just is what it is. Like, literally, it took us 2 hours to write less than 5 lines of code. Are we serious? Are we serious? 4 lines of code took us 2 hours? Oh my gosh. I feel like kind of like a failure, but it is what it is. You'll probably use classes way more than you use recursion, depending on the field you go into. Hopefully, I like when I learned about object orientation in CS50P when he was going over what objects were, and I was like, "What are you talking about? This is programming. How can we have objects? Like, what are you talking about?" I was just so like bewildered by like this concept that you could have, you know, entities in itself, like custom entities in programming. But now it makes sense because how else would you create like bodies of whatever to house? And it's just, it's a very, whoever came up with that concept is really really smart. Like, whoever conceptually created the idea of classes is just really smart. I mean, this book talked about like the 10-year-old, right? This book had an example of that 10-year-old that figured out that sum equation, like in art, like from back in like in the Greeks. Is like, how are these people existing? It's just, hey, SFD Tech, I appreciate you coming in. Welcome. Thanks for finding the channel and coming in and saying hello. I appreciate you so much. Michael Gardner, that's what it takes, man. Sometimes it takes a struggle. Yeah, I mean, if maybe that's what'll set us apart, right? Is that if we're willing to go through the struggle to learn when other people were giving up, maybe keep that mindset. Someone else probably had given up an hour ago. Someone else gave up an hour and a half ago. Someone gave up 30 minutes ago, but we were able to push forward. And, it's not a competition, but maybe that mindset can help you, be like, I need to keep going. I need to keep learning this. Someone else just quit. Like, odds are someone stopped doing their homework or whatever because they got bored or tired of it, and I don't know. All right. 4 lines of code, 2 hours. Thank you so much for your patience with me. I every day I think I learn recursion a little bit more and more, and then I come back the next day and I'm like, struggle. I mean, but I am getting good. I will say I am getting good at the recursion traces though. Um, like these days, like, right, the recursion traces that I've been drawing, I've been pretty good about being able to understand, and so maybe I should just take that approach. It seemed like I got a lot further when I used your guys' advice about writing out the recursion, drawing out the recursion trace first, and then trying to do something. Stop trying to keep it all in your head and write it out, right? Do a recursion trace for an example, and then and take that, right? We definitely got a lot farther in that last half hour when I pulled out the whiteboard and started drawing, right? Thank you guys for those suggestions. You guys are great. For those of you new here, I'm Michael. I'm teaching myself programming. I'm learning Python for the past 6 months pretty rigorously, and I've been really pushing myself to learn and put in the hours needed to be successful in this. I completed CS50P, was my first ever um, ever attempt at programming and learning that field. It was really, I'm not going to lie, CS50P was pretty hard for a raw beginner, someone that never seen a line of code before. I had to, learn as if you're trying to learn Spanish and never heard a lick of Spanish before. Odds are you've heard some Spanish, hola, wada, and so you were able to kind of pick out some stuff, but I had never seen a line of code before. So that's like as if I was going to try to learn like German right now. I've pretty much never heard German before, like really, like besides maybe in some movies, but uh, like I never ever tried to follow German, and so it would be like the same. It was like the same thing. I was completely such a steep learning curve at first, but then once I got comfortable, I really got the reward. You get this feeling of accomplishment when you accomplish these learning tasks. And so I have a degree in human biology, a bachelor's of science in human biology, and a minor in chemistry. I studied more specifically the like fundamental cell functions of human biology, kind of more on the protein levels, cell biology, things like that. I got a job as a formulation chemist right out of college for a biotech company where I make biological controls used in like in vitro diagnostics and clinical testing. So, patient testing, diagnostics for diseases, certain, just control values to provide necessary, accurate results for physicians and clinics and hospitals. So that's currently what I do. And so I'm learning programming to maybe combine the two together, right? Maybe I can learn maybe some AI or something to develop a feature for detecting abnormalities in certain cells, right? That'd be kind of cool. Or so, anyways, we're just getting into these. We're learning and we're reading data structures and algorithms in Python, and so we're doing the needed necessary learning before we can really take off with the freedoms. But also, guys, and I also work on projects, so I implement all the learnings that we do into projects. So it's actually cool. A couple of days ago, we actually wrote a binary search algorithm for our small business manager, and we ended up refactoring our code into a different data structure. And so we didn't actually need to implement a binary search. We can now access our items in constant time via just having the item number for our certain values be the keys of a dictionary. So we don't need to do any looping over unknown values and splitting in half with a high-low on a binary search. So, but we were successful in writing that binary search in. So that just goes to prove that what we're learning in these books we are using in real-world problems. So for those that don't know, I'm writing a small business manager project which will take in items as inventory, process those items into for sale and sold, manage those attributes accordingly with those items, maybe even take in expenses, and then ultimately formulate like business reports needed for those transactions and those various report costs of goods sold, income statements, expense sheets, all those kinds of necessary business statistics. We can provide those to small business owners that may not know how to calculate themselves, manage or track all that inventory, or maybe just don't care to do it themselves. So they can have a program here, hopefully on GitHub for free that we can all use. So we've got a lot of stuff implemented into this, but right now I'm having a good time going over these practice problems. We're almost done with the chapter 4 practice problems, so I want to just keep going here really quick for today. We are so close to being done with chapter 4. So yeah, in the beginning of my streams, you guys, I read aloud and do practice problems from various textbooks. Right now we're doing data structures and algorithms. Before that, I read all of Python Crash Course live and did all the try it yourselves live. we'll dive into Fluent Python, and then we'll dive into Python machine learning. So we got a lot of books that we're going to cover here on the channel. Follow along if that's interesting to you and something, a topic and subject that you also enjoy learning about. Even if you already know it, it's always good to just come in and provide feedback and input to those like me and other people that are learning it too. We had a lot of people working through these problems with me, throwing, spitballing ideas, certain lines that they think would work in these problems. So we're all working together, and that's the whole goal of this channel, is to get everybody together and just take the pressure off of things and just have a good time and learn. And yeah. Writing comments is huge. Definitely good practice. Yeah, I definitely need to probably, before I even dive into recursion problems, write out a trace for it, right? Yeah, someone in our streams in the past couple days mentioned bioinformatics. So I might need to look into that field, maybe like start creating a project that I could showcase to future employers or something like in that realm. So, it's definitely something I'm interested in. I need to look up for sure. I'm doing a similar project with chemical inventory at work. Oh, awesome. You feel free to check out my inventory, my CS50P final project. It's very simple and basic, but it was just a inventory storage manager. And I used it specifically for like chemical materials and stuff. So yeah, I kind of did something along those lines too. That's really awesome. Okay, so let's go into R4.7 underscore key dot pi. Okay, 1, 2, 3. Oh boy. Describe a recursive function for converting a string of digits into the integer it represents. For example, 13531 represents the integer 13,531. Converting a string of digits into an integer it represents. Oh, so this is there's you're missing some quotes. Okay, so we need to recurse through this string for every level of recursion we go, we need our magnitude to also increase. So this is what we need to do, in my opinion. We're going to have some string, we're going to have some function called convert, and it's going to take in some n value, right? So it's going to take in some string with a length n. In our first, let's say we have a C of 5. So we're gonna take in, so actually we're gonna have a string, right? This is a string. A string. We take in a string. We need to take the length of the string and set that equal to n. So now we have C of some value n, right? Right. Now we have this. So let's say that n in this case is 5. So C, or let's use 4 or 3 actually for just better. So this case is 3. We need to, our base case would be that n is equal to 1, right? Meaning that we have reduced this string down by 1 to the 1. So our base case would be that we're getting all the way down from C2 down to C2 down to C1, and we've reached our base case, right? So if we've reached our base case with C1, what we need to return is the value of n times this is my idea. We want to turn n, so this is going to be 1, times we need to get the magnitude at this. So this is the ones place. So this is going to be times 1, right? So then, so times n in this case. So then we're going to say, we're going to recurse back. And we need to, this is going to return n times n, or in this case, 1 times, if we do times 10, it'll be 1. So we need to do n so my idea is we need to, we're at the tens place now, right? So we're going to recurse down n minus 1 each time until we get to n equals 1. And n equals 1 would equal this value of 1, right? So then at this point, we need to take the value that n is, which is 1, and use it and multiply it by 10, multiply it by 1, because it is 1. So yeah, so n times n. Then we come back to the second value. So I'm just gonna, let's say my example is quote 321. So 321. So I can break this up into a 10 plus a 1 plus a 20 plus a 300, right? So I need to multiply the n at that position by its magnitude, in the recursion, in order to right? Or am I making this way harder than it should be? That was my initial approach, is I should locate down to the last integer value in the string, convert it to an int, and multiply it by its magnitude, and then return that plus the next recursion, right? What do you guys think? So if c is 1, if our example is c equals 3, we go down to c equals 2, we go down to c equals 1. We're at this one place. We're at this value 1 for n. Well, our 1 doesn't physically, our 1 represents n, but 1 is the amount of characters in the string. So we have 1 character in the string left in the ones place, because we've broken this all the way down to the ones place. So at this point, we need to multiply the value of n times see, here we go again. This is, oh boy. So we say def convert with some string, right? If string, okay, so we're going to take the length of string, n is equal to the length of the string. We need to set if n is equal to 1, meaning that we have the final character we're going to return n, return 1, right, back to the function, else describe our recursive function converting a string of digits into the integer it represents. For example, I'm not sure if we have to consider negative numbers. It doesn't really tell us. Let's just assume, like with this example, right? Let's just assume like the example. So if we get to the last one, we return 1 back to our function as our function. So what do we do with this 1? Well, we know that this is the 1's place. Else we're going to say, we're going to call convert on string. Oh no, so we can't do that because we can't go string -1 because we can't, reduce from a string. You return the 1's place number for the base case. Return we gotta say for I in range of n plus 1. We need to say if n is equal to 1, return n at index I. No, we don't want to loop like this, right? We need to capture the index value so we can return the physical 1. So for I in the range of n plus 1, we have the index, so we can say if n is equal to 1, return so what if you say if n is equal to 1, n index 0. This means we'll return the first value of n. We'll return this value. Okay, so we will return n at index 0, meaning that we will return that value in the string. So we will return 1. 1 will be returned, and so we need to call convert string. So if we call convert string again, we cannot say string -1, right? That's just, we can't do that because okay, we can convert n -1 as string, right? We can plug n -1 directly as the string, which will just be 4. Which is not what we want because we need Any ideas, you guys? Any ideas? Chat is awfully quiet on this one. So the thing is we have to convert these strings to integers somewhere, right? We need to return the int conversion of this value. So that'll convert. So we need to index. We have to index. So if I is equal to if I becomes greater than n, return int string 0. If n is equal to 1, return int string 0. That'll return the physical 1 in the string, convert it to an int, and we need to multiply it by if n equals 1, we want to return 1, which will return 1 as this value. But the thing is, you guys, is we can't, how are we going down? Like, right? We can't, how are we going to go down this string? Then multiply by the quote place for the other digits. What about this? What if it wants us to do this? What about this? What if it wants us to find the length of the string, take that length, right? We'll set holder, placeholder equal to 0 times n. So if we have a string with a length of 5, we'll have 5 zeros as placeholder. We need to say so if we have a placeholder number with zeros now that we need to fill in with the digits corresponding to the index values at each recursion point. So when C comes down to 1, so we need to say if n is equal to 1, return int string 0. That would return the physical value 1. Else call convert on the string again. Oh, here we go again, you guys. Here we go again. Here we go again on my own. I've been down this lonely road I've ever known. I was born a dream alone, alone. Okay. So if we want to describe a recursive function that represents, so let's go back to our trace here. What do we exactly need to do? We need to find how long the string is. So we need to take the length of the string. Okay? Now that is the amount of digits that we know we need to have. I don't want to loop through my string every occurrence, right? Like that just wouldn't make sense. Like if to loop through at every occurrence. What was I trying to look up? Your base case is a single digit. Yes, so how do we get there though? The thing is we have to reduce by some value. Which is the ones place. Ugh. So we need to take the length of the string. So how I'm trying to figure out how can we iterate down this string? How can we reduce down the string? Because we can't call a negative on the string. We have to call minus on the length. Convert So what if I say like I am trying to recursively convert a string into an its integer. Don't show me code. Walk me through how to get started. Understand the problem. You say you have 1, 2, 3, 4, and you want to convert it to 1, 2, using built-in functions like ints or loops. Identify the base case. In recursion, there's always a base case that stops recursion. The base case is when the string only has one character. For example, the input is 7. We know the integer is just 7. So we want to return the int of string at index 0. So we want to return that value converted. So we want to return that value converted. So that'll get returned here. So that'll get returned here. So set 1 will be returned here. Else we return the singular base case. So literally int 1 will be filled in for here. What do we need to do with this? We need to multiply this by n is 1 in this case. The length is 5. So we need to multiply this string by, okay, so this would be by 10. Right, so this is going to multiply this, so 7, 1 is going to, so we're going to return it was okay. So I'm thinking about this wrong. When n is equal to 1, meaning that we have broken the string down all the way to the ones place, we convert this integer 1 into it's kind of confusing because n is equal to 1. That's not what we're saying. We're talking about the place of the string. So there's only one length of the string. So, and that would just be this ones place, which is a 1 in this case, by chance. We convert that and return it. So we get that return back in that previous iteration, and we multiply it by 10. No, we need to add it to our string index I feel like you want and beyond. Yeah, I had to use string slicing. The input has to decrement each call. Yeah, so the increment has to, so we have to use a slice here and go from, if n is equal to 1, we need to do a slice of from n, the current n value, so n is equal to 2, so n 0, n -1, convert the last integer. So this will we get 1 back from this statement. So and then in the previous next recursion we got 1 back here. You will either need a count parameter for the number of SI digits, or you have to slice the string. So let's first, so with the count, we would have to keep a count to factor in the magnitude that we're in. So ones, tens, whatever. So one. Need to track the index, I think. The length would be reduced. Oh boy. Okay, so we want to, you can think of it as the function process one character at a time. So 7 gets returned. Okay, I'm not going to use that example. I'm going to use this example. String 1, 2, 3. Okay. 3 gets returned when we get meet our base case. Okay, 3 gets returned, so we want to run convert for n slice of n, or string, no, a string with, so if this is 5, we need to do 4, so n minus 1. Like that. No, because that'll access the fourth value of the string, or that'll access the numeric value of the string. So we need to say n through convert, go down, go to n. Like this. N is my length, not the index. Yes. So n is my length. Slice off one character on each iteration. So how can we make a slice again? We have to do this. This creates a slice of the string. We need to do slice off the last character like that. Or go like one on, like this. So this will return a string. So this is going to return literally 3. We need to take the 3 and add it to so the 3 gets returned as the convert function in our base case. What do we need to do to the 3? We need to add it to the previous recursion steps. Gosh, I hate this. I feel so dumb. I cannot solve these freaking problems. Think of how you can process. Take the last character of the first character, convert the character into integer form using recursion used to process the rest of the string. For example, process 4 and recursion to convert 1, 2, 3. You can keep adding the integer value to the current character. You can keep adding the integer value of the current character to the result of the smaller subproblem. So if n is equal to 1, we return... You're off to a great start. Let's build... Don't show me code. Okay, base recap. When the string only has one character, you already know the answer to the integer value of that character. Recursive step. Take the last character of the string, the rightmost digit, convert it to an integer, solve a smaller version of the problem by processing the rest of the string, everything except the last character. Combine the two results. Multiply the result of the smaller problem by 10. Shift the digits to the left. So it is by 10. like I had before. Don't worry, this one made me think a bit. I've been programming a few years now. So how can we generate a slice? Is this the slice that we're looking for? Is from one on, right? We're going to skip over the first value and go to the next, or we're going to go from 0 to -1, right? We're going to leave off the last character. Oh no, we need to go like this, one forward. Yeah, one forward is the slice you used. So if I go, I need to return this. So what if I call print on convert quote 1, 2, 3, 300. So that's just multiplying what if I do that? I get 3. I just got the 3. So if we convert string 1 through we need to add it though to the previous iteration. So 3 was detected here. What am I missing? So I have this. You're on the right track, but there's one key part. You need to handle the current digit and combine it with the rest of the recursive call. So plus recursive processing the smaller string, but after processing the smaller string, you need to shift its result by a factor of 10 to account for the place value of the current digit. Recursively calculate 23 gives you 23. Multiply 23 by 10 to shift the digits to the left. So we need to just multiply this by 10. This will give us 300 again, though. What number does the... Think of it like, what number does the first char represent? Then add to what the next char represents. Okay, so we need to int no, that's not right. Gosh, come on. You need to adjust the 10, then 100, then 1000. Yeah, so we need to how can we track the magnitude though? By the level of recursion that we are deep? So if n, we know that n, or n is going to be going down. So we go, do we multiply by some factor of n? So 4 would be 1, 2, 2 would be 4. No, we wouldn't multiply. Minus 1. So return n minus 1 times convert. So if 3 gets sent back, we multiply 3 by n, which is 1, which would be 0, which is 0. No. So that wouldn't work. But n in this case would be 2, minus 1 would be 1. So 3 times so n gives us information about the magnitude because we're n levels deep. If we're n levels deep and we multiply by n here, we got 18 there now, and that's not right. We want to multiply by n, which is the length. So if the length of this one would be 2, so we're going to first take the 3. The 3 is going to be determined here. It's not here, so we're going to call the next iteration. So we need to multiply it by n every time. So the 1 will get returned multiplied by 3, which is, this is the hundredths place. And this is the, if the length of 3 determines the hundredths place, how can we, what does 3 and 100 have in common? What can we do to 3 or n to get it to resemble the magnitude? The length of the string decremented. So if n is 2, so let's say we need to convert this 1, right, into the 100, because we're gonna get back. So we're going to convert the 1 into 100, and this is the n is equal to 3 in this case. No, but it only convert that singular digit. So if I draw this out, we take in some string, so convert for 5 would go down to convert for 4, go down to convert for 3, 2, 1. So n determines the place value of the current digit. So if n is equal to 1, we return that singular value and convert it to integers. So we're going to break 1, 2, 3 all the way down to just the ones place. We're going to get that and convert it 3 and return it. Okay, so 3 gets returned. So let's say we have C is 3. C goes down to 2. C goes down to 1. Okay, 3 is generated and returned to this function. We need to add length of 2 string at index n. So if we convert string index n, we'll take the 2 int string index n times 100 plus convert that. Is that it? Nope. Since you're taking from the back, each time we go back, we get 10, 1, 10 times 10. So we need to multiply by 10 each time. So we need to convert the 2, like that. I think that might be. So if n is 3 in this case, 3 gets returned in this state. Okay, 1, 2, 3 is our string. Okay, 3 is the value that it is converted and returned in this int statement here. 3 is what ends up right here. 3 is what ends up right here. We need to add 3 to 10 times this 2 value. So string at index. So the length at this position isn't not 2. Three plus int string 10. I think it's just something's going on right here, right? I'm not accessing the right value in my string. So what do I need to do to n? That's 63. That's not it. That's not right. Uh, I'm struggling, boys. Struggling bad. Okay, so n is the length of the string. Multiplying the 10. So we have to add the 3 right, in the ones place. This is going to be in the ones place. By, hold on. Hold on. We have to multiply 3 by n, because n is going to be 2 in this case. No. So n is going to be 2. I'm going to use a different example. I don't like how I don't want to use anything with similar numbers in the place. So let's do like 657. So now no numbers represent the n value in terms of this the same number, right? So the number 657. We're going to go all the way till n is equal to 1, and we get the 7. So 7 is returned right here. We need to take that 7 add it to I feel so dumb. So this has to be added, right? We don't want to multiply the return by anything. We need to multiply the base. We don't want to multiply the base case by anything because the base case is in the ones place. So we return the 7. We add it to times that. No. This is crap. The first part, let's write, I'd focus on the magnitude multiplying the quote 10. But after processing the small string, you need to shift its result by a factor of 10. So 3, okay, so if we go back to our example here, when C goes down to 1, 7 is generated and returned to this function. We need to take 7, add it to the string at index value 2, which would be, in this case, string of index value n, which in this case would be 5. Well, we need to add it to 5 times 50, or times 10, which would give us 50, for a total of 57. We need to return this to string at index. Okay, this is where our problem lies. So we're turning it to string. If I tried to take the index of n here, 3 in the second iteration, you return 50, then another call for 100s. So 50 is returned, plus the string at this index times 10, or times 100, because it's the third index. But what the 3 doesn't tell us. I don't get how we're supposed to go up by another factor of 10 using the 3 as n. Like, n doesn't do anything, like, for that 3 in my eye. Like what does an n value of 3 provide us in terms of getting to 100 as our magnitude? You can view it as char's numerical value plus convert string 1 over. Ten times string so we have to multiply by a magnitude of 10. I know this is wrong. I just want to know what it says. Multiply the result of critical by 10. So we just need to say string 0. This will be the first character in the string times 10, the first character in the string times 10. Can only concatenate stir, not int to stir. The int call here, 117. The n is the number of trailing zeros. 3 hundredths. 3 digits. On the right track by sticking with the first char of string. Ten times 300. This sucks so bad. I'm fried. The n is how many trailing zeros of the 10? Yeah, so if we had n equals 3, we have 3 total values in our list, right? In our string, exactly. So if we, what happens if I just add it to, if I just return this? What do I get? 18? Not even getting 7 plus. Oh no, but it's adding, right? So that's what it's doing. I'm not supposed to add per se because I'm not concatenating. Oh, I'm thinking about this wrong. I'm not concatenating integers together. I'm adding integers together. So 7 plus the int string, which would be 2 times so if this is now 5, what do we need to do to this 5? We need to multiply it by 10 to get it to 50. But if we multiply by 10, we'll only get the 6 to be 10. We need a 6 to be 6 to, so we need to multiply by 10 to the power of n. Do we multiply by a 10 to the power of n? Is that it? Am I? No, that's close. Okay, I got 6507. Oh my god. Minus 1? I'm just guessing now. Oh! Oh! Oh my gosh! Oh my gosh! Whoa! We did it! We did it! Woo! An hour later, yay! One recursion problem, yay! My dog hates me for that. Oh my gosh. This one was hard. This one was really hard. Oh my gosh. This one was harder than the last one. If we tried this one first, we would have been doomed. Gosh, dude, I appreciate you. I appreciate you guys letting me get the answer and helping me really get there on my own. Like you guys were really helpful and like, wow, that sucked. Okay, so what's going on here? Let's see what's going on here. I want to write it out. That was wild. Oh my gosh. I'm so like, oh, that was crazy. Okay. So what's happening here? So if our string is 657, we're meeting our base case of n is equal to 1 for the length of the string. So we are returning 7. 7 is being added. We are returning 7. 7 is being added to the string at index 0 for this current iteration. So the string, the one previously, so I know I got it right, but I'm having a little bit of difficulty interpreting this right here. So this is taking the first string as we slice down. So taking the first character of the slice string. So we're going to go from 657 to 57 to 7. Okay, so this is going to be 657. This is going to quote. This is going to be quote 57. This is going to be quote 7. Right? 7 gets converted into 7, which gets taken as 7 plus. We take the 5 value, we take string at 0 right here. We take the 5, we convert it to an integer, and we take so you take 5, you multiply it by 10 first to the power of 2, that would be 100 in this case, but we need minus 1, minus our n, minus 1 I mean, so you get to 10 to the power of 1 times 5 plus 7, which is 50 plus 7, okay? That gets filtered back here. We take the 6, we convert it to an integer, we multiply it by 10 to the power of 3 minus 1 to give us 100 times 6 for 600 plus 57 for 657. Oh my gosh. Okay, so by carrying the strings down in my trace helped me to trace what I was doing and accessing them. Okay. That was really hard. I felt so dumb, guys. Like I felt brutally dumb. I mean, it is good to feel dumb. That means we are learning and we are going to be better next time. We're going to understand this next time when we see a similar problem like this. But yeah, I'm not going to lie, it was a struggle. It hurt for sure. Oh my goodness. Oh my gosh, I really had to think about this part. I really had to think, okay, what do I have to do to the 10 to what in relation to 10 and the n is there? Well, it's not multiplying it. It's not subtracting from n. So I was like, what other operation do I have to do to? I was like, just by or I was like, exponent. So I just and then it makes sense though because if your n is 1, it'd be 10 to the power of 1 is 10, 10 to the power of 2 is 100, 3 is 300. So if you're dealing with magnitudes, just keep this in mind. Magnitudes, powers go hand in hand. Magnitudes and powers are hand in hand. So if you have a problem that you think you can solve it by tracking a magnitude, just know that you're probably going to have to deal with a power at some point. Oh my gosh, that was fun. Well, okay. Well, it's like 11 o'clock, you guys. I got work tomorrow morning. Um, I've been going since I go to work. I get up at around 6:37 and I go to work at 8 and I get there at 9 and so I've been going since 7 a.m. this morning. So I do 12-hour plus days in just terms of raw brain power. So I get pretty tired towards the end of these streams. So it did not help me at all to be tired trying to solve this problem. Maybe if I was a little fresh, that might be naive actually, thinking that I'd be better if I was fresh. But now I really appreciate you guys helping me coach me through this problem, and hopefully you guys are able to also like refresh your memory and um, just remember when you have a problem that you want to track magnitudes, you're probably gonna have to do a power tracking it somehow. Okay. Interesting. Okay, wow. All right, this is the last problem of the chapter. I'm going to do this one tomorrow, and then we can dive into chapter 5. But I'll just read this one. Isabel has an interesting way of summing up the values of sequence A of n integers, where n is a power of 2. She creates a new sequence B of half the size of A and sets B of index I is equal to blah, blah, blah. If B has size of, oh my gosh. Okay, yeah, we will tackle this one. Um, we will tackle this one tomorrow. I don't want to think about this one tonight. You clearly know how to learn effectively. If you stay consistent, you will be cracked. Well, thank you. That's the goal. I want to be good at this stuff. I want to be fluent. I want to be have like a mastery in it. So, I want to know what I'm talking about. So, anyways, I really appreciate you guys joining me this evening. If you guys enjoyed the stream and want to support, just feel free to throw it a like, follow the channel. Um, I stream Monday through Friday. At least I try my very best. I have been Monday through Friday about 7 p.m., 7:30 p.m. maybe to about 9:30. Today we went all the way to 11 because we were just so in a kind of a mental flow state trying to solve these problems. I just couldn't. I did not want to go to bed not solving this. It would just be a defeat on my end. I wanted to get it done. But yeah, I'll see you guys tomorrow, same time. Thank you so much for the support. Follow the channel. Join the Discord down below for stream announcements, for all my study resources, for offline chat, for whatever else. Yeah, I'll see you guys tomorrow. Thanks so much for joining me today. Thanks for all the help. Bye, guys.